I've been asked about this box here indirectly dozens of times. Nobody ever knows that they're asking me about this box. They're always asking me about what this box is controlling instead. This box is a temperature control unit, a homemade temperature control unit. And I keep coming up with different ways of using this in my shop, and I'm so glad to have it in my shop. The primary thing that I use it for is controlling this silicone heating blanket that I use to bend ukulele sides. I've got a sandwich of spring steel and then the wood heating blanket, and then between the wood and the heating blanket, a thermocouple goes in. We'll talk more about that later. And then another piece of spring steel, and I heat it up to about 300 degrees or just under 300 degrees Fahrenheit and bend it around this form. You see controllers like this on commercially available side benders that you buy from a luthier supply company, but I didn't build this box with side bending in mind. I actually built this box with chair making in mind. So I don't show this part of my shop very often. It is uninsulated. It's basically a shed and right next to the road with logging trucks driving by all the time. In here lives my kiln, my light bulb kiln. And basically all this is a box big enough to put chair parts in and a light bulb, an incandescent light bulb. I've got, I don't know, probably a 200-watt bulb in there, some foam foil insulation, and that's about it. And that light bulb plugs into the heat socket, and over here there is a thermocoil, and this is a stick-style thermocoil, and it just jams in there, and I can set a temperature. Normally for the light bulb kiln, I'm going for 140 because I'm trying to just heat up the moisture in the wood and let that escape. In the top of the kiln, there's a couple of holes drilled to let moisture actually escape. And then in here, I have a little muffin fan, and I plug that into the aux side, and that is controlled by the switch. And that just keeps the air circulating around. And I know what you're thinking, Ben, you don't really build chairs much anymore. And you're right, I don't. But what I do, I 3D print with flexible filaments a lot. And these need to be dried out before you print with them. So this kiln, more often than not, is used now for drying out TPU flexible filament. The roll of filament just goes right in there, turn the fan on, close the door, give it 6, 10, 12 hours until I remember it, and it dries it out. It's super handy to have. My wife has used this kiln to kill bugs that were in a supply of wool yarn she got. It's been used to set bends from hot pipe bending. It's been used to do all sorts of things. Yes, I'm not a chair maker. Yes, I use this kiln a lot. After the light bulb kiln, the next thing I used the temperature control unit for was this. This is my hot pipe bending rig, but it's likely unlike most hot pipe bending rigs that you've seen before. Most hot pipe bending rigs use a propane torch and a floor flange and a piece of black steel pipe. And the torch basically rests in the back, and the flame from the torch heats up the steel pipe, and you've got a hot pipe to bend on. For some reason, and a lot of people roll their eyes at me when I say this, the idea of the open flame in my shop just kind of didn't make me feel great. And also, I wanted to be able to control the temperature. I wanted accuracy. And this combination allows for just that. So in the middle of the pipe, we need something to make it hot, right? And this is, well, first off, this piece of pipe is a piece of 2-inch inside diameter. It's like 2 1/4 outside diameter, black steel pipe. I also have 1.5 inch with a bushing to fit as well. I have 1 1/4 inch. I've never used that, but most of the time I think the 1.5 inch is on there. But on the inside of this pipe is a light bulb, and it's an incandescent light bulb. I believe this is probably a halogen element inside, but it doesn't matter if it's tungsten. I got drill bits on the mind. Tungsten carbide, no. Whatever. It doesn't matter if it's an old school filament on the inside or halogen. You need an incandescent bulb that's going to get hot. This is a 120 watt tube light bulb. I got it from 1000bulbs.com. That's a website that's super great. You can get any light bulb from there. That screws into a porcelain light socket. It's got to be porcelain. Plastic light socket's likely going to melt and be a problem. And everything's just attached to this piece of OSB. And again, pipe goes on there. I jam steel wool in there to keep the heat from radiating out the front at me. And from there, a thermocouple. This one has 1/4 threads on it. A thermocouple gets screwed into the bottom of the pipe. I just drilled a hole and tapped it, and it doesn't need to be perfect. It just needs to sit in there. And like everything before, thermocouple plugs into the back of the unit. The light bulb plugs into the heat socket. And if I pull out the steel wool, you can see the light bulb turning on. And if you wait long enough, you will see the temperature start to rise. The first couple of ukuleles I built, I did use this to bend the sides. I moved away from it because it is a higher skill process than someone like me who builds 2 ukuleles a year at best is able to pull off. By the time I get good at it, I don't do it again for another year. But I still do break this out to tweak a bend from time to time. And it's just a great thing to have in my bag of tricks. This doesn't take up much room. This is used all the time, and I'm happy to have it. All right. I'm going to set this to 335. And the water really just keeps the heat transferring into the wood as far as I understand it. I unplug it when I walk away from it every single time. This is where I was gonna bend a ukulele side, but I'm not gonna lie, that takes focus and bravery and more than I'm willing to give for a demo video of a temperature controller. So if you've made it this far and you want to build a temperature controller for one of these operations or something I have yet to think of, And if you do, let me know in the comments below. Let's pop it open and I'll show you what's in the box. Okay, I made this schematic and I've recorded this about 3 times, but the battery keeps dying in my mic. I think I have it figured out now. If I can figure this out, I should be able to figure out how to power the microphone. So, this is your mains power. In the US, it's 120 volt. Abroad, it's even worse. It's 240 or 220 or whatever y'all do. I'm not going to guarantee that this works for European outlets or anything 240. This is just, should work for American 120 volt. Your common comes out and is split 2 ways. First way goes off and completes the common element of your outlets. The second splits off and goes to the temperature controller. Your hot lead comes in and splits 3 ways. First one goes to the switch. If that switch is closed, it goes to the aux outlet. The second split comes off and goes to power the temperature controller. The temperature controller's probably got a little microprocessor in there. It needs 120 volts to power it. The third split comes off and goes to the relay. And that relay then, if it is closed, continues on and goes to the heat switch, which if it is closed, goes and powers the heat outlet. In between the temperature controller and the relay, there are these 2 little leads right here. These leads don't do anything, but they send information from the temperature controller to the relay. The temperature controller tells the relay to turn off or on. This big honkin' relay is probably a little bit overkill. I do believe there are temperature controllers that you can do the 120 volt switching directly from the temperature controller. This wasn't that much more, made me feel a little bit better, and it was worth it to me. The only other element that is not on the schematic is the input from the K-style thermocouple. That is right here. Originally, I started off, I just had the lugs here, but that got annoying to unscrewing and screwing them in all the time. So I got the thermocouple style receptacle, and that's about it. Now, I should say, some of you might have noticed that there is no grounding to this circuit. There is no ground to this circuit, and there should be. In my defense, it is controlling light bulbs, and it is controlling 2-prong heating blankets, and that's about it. But, folks, we all know there should be a ground on this circuit. If you make one, you should add a ground to it. Any and all things that can be grounded should be grounded. You know that, I know that. Do better than I did. So you've seen what goes into it. I will post a crude schematic to woodworking.com, link in the doobly-doo. If you feel uncomfortable working with electrical, this is not a project you should take on. If you're unqualified to do such things, don't do it. I will try and find and link some all-in-one packages that do pretty much the same thing. You might be able to just open up and plug them in and go. I can't attest to the quality of any of them because I have my own. But if you have one that you found and you trust, list it in the comments below, share it with others, and maybe this made you think a little bit. Chances are pretty good that you don't really need one of these, but once you have one, you'll probably find new ways of using it. So if you think you might need one, just do it.